Bismillahirrahmanirrahim. So let us discuss multinomial probability law. So for this, let us consider sample space S of some random experiment. Let us consider a random experiment with sample space S, right? And let there be a partition B1, let B1, B2, B3 and so on till Bm be a partition, be a partition of the sample space S, such that probability of Bj, any of this Bj is equal to P subscript j, right? So we have this partition B1, B2, B3 until Bm, and the probability of each of this B1, B2, B3 is equal to Pj, right? So the events are, suppose events are mutually exclusive. So these are mutually exclusive events, so that the sum of these probabilities is 1. So such that P1 plus P2, P1 is probability of B1, P2 is probability of B2, P3 is probability of B3 and so on. Pm is probability of Bm and their sum is 1, right? Now suppose that, there are n independent repetitions of the experiment, and let Kj be the number of times event Bj occurs. So that K1, K2 and so on till Km specifies the number of times each of the events Bj occurs, right? So we have this partition B1, B2, B3, Bm, right? And the probability of occurrence of each of these is, for example, Pj. For B1 the probability is P1, B2 is probability is P2 and Bm is the probability is Pm. Now we suppose n repeated trials and independent repetitions of this experiment, such that event B1 occurs K1 times, event B2 occurs K2 times and event Bm occurs Km times, right? So this specifies the number of times the event, a specific event occurs, right? So the probability of exact occurrence that K1 that B1 occurs K1 times, the K and B2 occurs K2 times, occurrence, the probability of occurrence K1, K2 and so on till Km is given by multinomial probability law. So that is probability of k1, k2 and so on till km is given by multinomial probability law. So there are n number of repetitions, so n factorial divided by k1 factorial, k2 factorial, k3 factorial and so on till km factorial, right? And p1 raised to the power k1, right? b1 occurs k1 times, right? And the probability of b1 is p1. So p1 raised to the power k1, p2 raised to the power k2 and so on, pm raised to the power km, right? Km. So this is the multinomial probability law, and binomial probability law is a special case of this this multinomial probability law. So if m is equal to, we get binomial probability law for that specific case. So in that case, when m is equal to 2, we will get the binomial probability law.